All right, so let's continue on. I'm going to once again take a seat because I've got to drive. And we're going to now build some of the decks. Okay, so let's turn back on some of the geometry. So we'll turn on deck 1, deck 2, deck 3. And again, they're not there, so I turn on visibility for all objects. And there the deck is again. Okay, so now I need to turn off the visibility for the thermal desktop stuff. And I'm going to copy these 3 CAD surfaces from the center line, center here, and I can just go perpendicular to this line, and it'll copy it over the distance that it needs to go. Okay. So now these 2 decks are pretty easy. They're just going to be disks. Pick a disk, go from the center here, go up, and I'll pick the endpoint here. And so here, I'm going to want some granularity. Let's see. Right, so 25 nodes angular and 9 radial. So we'll do subdivision. Again, I like my edge nodes, angular 25, radial 9. Makes a bunch of nodes here. Then we'll make a copy of that again. So when I want to copy this, it may be hard to pick this, so I could use a crossing. So in thermal desks, or in AutoCAD specifically, if I select out here and there's nothing, I can select to the right, it's a window. That means everything has to be contained within the window to be selected. I can go to the left, it's a crossing. Anything that is within this window or crosses the dashed line will be selected. So I could do a selection here for crossing and then remove by typing R to remove from the selection set the solid. So now I've selected 2 objects, removed one from it, and now all I have selected is the disk. So I can copy that from the center here to the center down here. So there I made a copy of it. So I'd call this one, and in this case it does let me select it sometimes easily, sometimes it doesn't. So there I would edit it. We'll call this new deck 1. Okay. Now you'll notice all the node numbers, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then it starts to increment. So what happens is eventually you get to a point where it wraps around. So this 26 will be wrapped around here by 26. That's where it starts at 0 and ends at 360. So the 1 is where it's collapsed both radially and circumferentially into a single point. So it'll give you a lot more node entries than you see nodes here because of that. If I were to give this a non-zero radius, then it would not have the 1 there at each of the points. It would be different for each angular section of it. All right, so edit that. Oh, didn't I change it? Escape. All right. Radiation. So again, we'll do radiation. The top we're going to do is white paint. Bottom we'll do is black anodized. Concap, we'll call it new deck 1. Make it aluminum. And what did I say this was? Yeah, just leave it there for now. We'll call it 5 inches. All right, so if I recall correctly, if we turn the ESPA back on, and that's the new ESPA main, let's rename this. So now if you zoom in, you might see that there's some surfaces that are cutting through. And there you can see it right here on this deck, primarily. So this is one of the places where we, made some of those adjustments that skew it a bit and aren't perfectly planar. So we might have to go into this one here and reduce its radius so that it doesn't cut through. So in this case, nominally the surface is 29.5, so we're going to make it 28.5, reduce it by 2 inches in diameter, and now it's inside there. You see the CAD poking through, but you don't see the thermal poking through anymore. So what that winds up doing when we did it later, and we had a deck down here that's a closeout, is that was a little bit too small, and the sun basically peeked through the gap there. So you're probably pretty close when you haven't mucked with the surfaces here. I mean, this has a curvature with the arc length to it, but it's really the ones here that we've had to move inboard further or outboard further that cause the problems with things coming out here. And I could remesh this and, put another element, do some triangular elements there, if it was really warranted. But what we'd find later is that when we use this 28.5, there is an area where the sun sneaks through, particularly at the beta 90 case, which is basically looking like that down at it. So, all right, so let's go ahead and turn off the ESPA again. And let's, where did my thing go? I don't know where my other disk went. Oh well, make it again. So these look like they shifted ever so slightly. I'm not sure why. But we can just say, hey, you know what? Let's move them down a little bit such that they're kind of right in the middle. Okay. All right, so let's deal with this one here, which is a little bit uglier to have to work with. So this one I'm going to take and show how to do the elements here. So we're going to do the same thing, convert this from finite difference to finite elements. Okay. And now I can start removing some of these elements that are in the whole area. Delete the nodes for them. Oops. And one other trick, when you want to select something, so say I want to erase, you can do a window polygon and a crossing polygon. So if I type in WP, I can now select multiple points. So this lets you more easily do a funky shape for a window to select things. And likewise, you could do a crossing polygon, which would be similar to if it's contained within the whole area or not. Do it. And then what I'll need to start doing is, just start making the adjustments here to move this to these points. So this point, I think what I want to do is move all this up a little bit so that it's right at the line. So let's go ahead and just do that. We're going to move, and again, because this is all elements, I now need to move the nodes. So I'm going to select everything, remove the So where they're basically right at the surface now. And so now you can see that I can start taking and moving some of these nodes. So let's actually use here and then say nearest. So similar to those grips for the surfaces that we saw, nodes have a grip. So if you kind of hover in the middle, it sort of snaps to it, and you can do move node and then do near. And it's not exact. I could be more precise about it, but again, perfect being the enemy of good enough. This will suffice. Not ear, near. So here I'm probably going to have to create some kind of a element to fill that in. That's one other thing. There's an OSnap, object snap, which you normally have on. And so these are all the different types of things that we'll look for. So if I were doing this a whole bunch, I could say, you know what, I want to add nearest to it and hit OK. So now as I click on this, there, near will show up here if it finds nearest being the closest thing. So that I don't have to keep typing in near every time. So now one of the drawbacks with this approach, you got all these nodes here dense in the middle that you probably don't need, but in the interest of simplicity, you just kind of live with it. So now if I were to turn off the CAD for this, you can see that I got a pretty decent shape. I may have deleted an element I didn't want to, so I probably would create one here and go 1, 2, 3, fill that in here, 1, 2, 3, fill that in. So now I've got a pretty decent little hole cut in my panel. Let me turn off these other two. And I would again use symmetry to delete a quadrant's worth of this and then mirror it around. So let's see if we do that quickly. Here to here. So let's do that the way that I just highlighted. That will be nice and easy. All right, so I want to erase window crossing. Let's go here. Oops. Erase. Now, why is it not like that? Okay, so I guess there's not a window crossing. This is just a window polygon. All right, so I go here. Come to middle here, there, go back out, around. Okay. So just a little bit of a few elements here I got to delete. So let's get rid of these nodes. Okay, so still a good center line here. It did delete the node in the middle, so we'll have to recreate that. So let's go ahead and do that. So I need, so I can copy this node from here perpendicular to this. That puts it in the same plane. And now I'll need to create the elements. And just to make it a little easier, we'll go ahead and do this as 1, 2, 3, 4 elements. So rather than being triangular elements, we're doing this as 3 quads. Okay. And so now Array Classic. Select the objects. Now, even if you don't have nodes selected, when you select elements that you're going to do, it will add the nodes to it to create them. So I could just select the elements here, and it's going to create the nodes in order to do that. So center point along here, preview. There you can see it created the nodes, and it's created my deck. We'll turn the nodes back off. Whoops. Preview again, hit return to accept. Turn nodes off, turn nodes on. And now I need to make sure I merge so that I have the free edges gone. So now if I do my free edges check, should just be the outside and the 4 inside. And then lo and behold, I've got what I want. So there I built my deck. Doesn't look too bad. We'll show how this deck gets meshed if you were to use the auto mesher in a little bit. But for now, let's see where we were with this. All right, so we got 3 decks. Deck 1, on. Okay. So now these decks need to be contacted to the ESPA. So here's another trick to show that's really useful. Let's see. All right. Okay. So we're going to connect these decks to the ESPA. So don't even have to have it selected to be able to use it. I can actually select things directly through the model browser. So I'm going to create a contactor, select deck 1, select deck 2, and then I'm going to select all the outside elements here. And I'm going to contact it. And now down here you can see I've got MB, domain, and group. So if I type in model browser, it's going to bring up its own little copy of the model browser where I could then select something. So I'm going to select ESPA. And it'll select everything in here. And when I close it, it's now selected all the ESPA objects. Now I hit return. And here is my, okay, yeah. So here's where I did something wrong, because I selected ESPA and not new ESPA. And so you can see it's got all this other stuff in here, not what I wanted. So let's go ahead and delete all these. And I'm going to then add again. And I'm going to do model browser. And this time I'm going to correctly select new ESPA. And hit OK. All right, so now I've got everything in new ESPA where I want it to be. So again, make my connections here. We'll go new ESPA. When I say 24 bolts. So in this case, instead of doing a per area or length, we're going to do an absolute. And so we're going to say that it's a watt per K, so it's 3 decks times 24 bolts times 2 watt per K per bolt. And so I'm going to put a reasonable tolerance in here. Let's make it 1 inch. I'm going to get rid of the apply surface. And then this is going to be in edges, not a surfaces. And so here, max radius, and then these are all going to be probably just first edge. Nope, they're all of them. So, all right, so all these are doing it for all edges, and we don't want that. We're just going to pick the first edge. Edit. All right, and hit OK. Okay, so let's make sure that contactors are turned on. Okay, so there are my contactors. So now you can see that this edge looks okay. That'll be the other edge on this disk. But all these other ones are the inside edge. That's not where I want it to make contact. So what is a really handy feature for just this purpose and no other purpose I have ever found in the software is this shift connectivity, which says basically instead of defining the element as node 1, 2, 3, and 4, I want to define it as 2, 3, 4, and 1, such that the first edge becomes different. So if I shift connectivity and select this element, you can see now, well, now this becomes the first edge. If I do it again, now that's the edge. So if I just keep repeating that command a few times on each of these, I can get the first edge to be where I want it to be. So now I don't have to guess which one is the first edge and which one's the second edge and which one's the third edge when I'm dealing with an edge contactor and elements. I can just say I'm going to always shift it until the edge is indicated that I want it to be. Does that make sense? Yes? Okay. And that's the only use I've ever found for the shift connectivity. The reverse connectivity basically changes the top side and the bottom side. This basically changes the order of the edges that is somewhat arbitrary in terms of what it does to the solution. But there now you can see that I've got all the edges lined up where I want. If I double click this, I can edit it. And now I can do a show calcs and see that, yes, indeed, I've got the connections where I want it to be. So there it had something for the min radius. We'll check and see what this error is. So, okay, so here it said max radius, but it still had this one checked as well, which says edge invalid for calcs. In this case, it would have been the min radius, which is 0. There's no radius there. It's all collapsed. This would have been the front edge for the start angle. This would have been the end edge for the starting angle. So we'll just uncheck this, make sure it's happy. Show calcs again. Oh, did I still have the other ones checked too? I may have. Okay, so yeah, so we'll keep getting that error message because I can't uncheck these. I'm not sure why it, deselect all, do max radius. Oh, no, it's because I only did it for one of them, that's why. No. There we go. That's why it's giving me that error. So, show calcs, okay, now the error goes away. So now I'm gonna get edge contact, from here, and it's gonna be the 24 times 2 times 3 divided by the appropriate lengths here. So, all right. Likewise, when I need to do the contactor for the next ones internally, if I had to contact the edges here, I would now know that this is going to be edge 3. These other ones I could then potentially shift. So, you can infer if I know that this is the first edge, regardless of whether I go around this way or that way, this would be edge 3. So if I needed to contact this to something, I could do that. All right, did that cover everything here? Okay. Another thing I haven't shown yet that's handy. So I need to go and define this here. So let's say that this deck and this deck are really going to be the same. So we're going to make these be new deck 2. Radiation is going to be both. It's going to be black anodized for both of them. Concap, we're going to say it's aluminum. We'll say that this is 0.3 instead of 0.25, just for something different. We're going to make it be new deck 2. Insulation, we're not going to put any insulation on it, so on and so forth. Now, suppose I want to apply that property to everything else. Down here, I could say thermal modeling tools, copy properties from master. So I'm going to select the master surface and then all the entities to which those master properties are going to be applied. And so now I can select all of these. And so now if I go in and edit these, I can just pick one, you can see that its radiation is black anodized, black anodized. Its concap is new deck 2, although we really want that to be new deck 3. There's no insulation, so on and so forth. So you could define, one of these and then propagate the changes you made to other ones as needed. So we'll come in here and let's go ahead and turn on the nodes again. Make sure that all these nodes are new deck 3. We'll make sure that this here, I can change the nodes by making it here on the subdivision numbering page. That's already in deck 2. So, all right. So that's an example of how we've made the decks and then coupled the decks to the ESPA or the new ESPA. And so now if I look at all 3 of these, I can see what the model looks like. I might say, let me make the new ESPA be a little transparent. We talked about that earlier, so I can say properties. And so I could say transparency, and let's do a selection. Select, no, so let's just do select objects. Here it doesn't let me do the model browser, so in this case, let me turn on just the new ESPA. And then I can select all of this. And then you can see I've selected 502 things. I can set the transparency to 85. It's 85%. And now I can kind of see through it and see what my decks are inside. Turn on contactors. So, all right, so I think that is it for the demo of the decks. And then this would just be the assignment of all the different optical properties and material properties and things for it. In this case, I think we had said that these would be honeycomb. So instead of being 0.25 thick, they're 40 mil face sheets times 2 in inches. So I'm just basically doubling the thickness of the face sheet and applying it. So did we say there was? Okay. All right, so this would be when you go through the real thing and you're doing it to go through yourself, this would be it. So that is basically it for the demo part for now. We will talk real quick about the mesh controllers, which we talked about. All right, so for those of you who aren't familiar with mesh controllers, they are an object in Thermal Desktop where you can select a part, a CAD part, and then assign very, very basic properties to the mesh, essentially just kind of the average element size. And that's really it. It's all going to be tetrahedron elements, which are basically four triangular-sided elements. And the outer shell, the free edges, free faces of that will be coated with triangular elements. So myself, I much prefer a quad to a triangular, mainly because if I've got a quad, I get the cross diagonals. If I've got 2 tris, I get this, and I'm missing this diagonal that's in there. So if I've got a bunch of those, I'm not really getting the heat flow in that direction. So when I can, I always prefer to do quads as opposed to 2 tris. Tris, however, are great because they're always planar. 3 points to find a plane. I could have a quad that has a little bit of a skew to it, as we've seen here. So there is that negative to it. But a lot of the meshes can much more easily fit triangles and tetrahedrons to solid shapes and planar shapes than they can quads. Quads are harder to deal with. So that's why you'll see more of the mesh controllers dealing with tris and tets than you do with bricks and quads. Again, you can create the mesh controller. It has 4 layers that automatically get created to it. So it assigns the mesh controller object to one layer. It assigns the solid part to another layer. It assigns all the 3D elements to a third layer and all the 2D elements to a fourth layer. You can select multiple parts, and you can have multiple mesh controllers for different parts in there. So it's really up to you. But again, I found that it has very limited capabilities, and let's go through that and see how it is now. So when we do this, we're going to mesh both the ESPA and we're going to mesh this ring here. And you can see this one I can probably get a pretty decent mesh. When I try to do the ESPA, it's just going to be way too much. So let's go through that real quick. Sorry to have to sit down again. So let's turn off all of the other thermal desktop objects. And we're going to turn back on the ESPA and CAD Deck 3. And so I'm actually going to need a whole ESPA, so we'll copy this whole thing over again. And we'll just copy it right here for now. All right, so this one, let's go ahead and do a mesh controller for it. So I'm going to come over here to either TD Mesher, or you have the option to do it here. So we'll go TD Mesher, and we're going to do mesh part. So it's going to first ask you to select a single entity to mesh, although I thought you could select multiple ones, but maybe not. And then you're going to do the display preferences as to whether you want to show it as a wireframe, show it as hidden faces. So in this case, we're going to do a shaded exterior faces, hidden interior faces. So it looks a little nicer. And then we're going to generate the preview. And so here you've got fraction of the max dimension or the absolute size. Those are really the only things you have. So let's just say, this thing is 60 inches in diameter. Let's say that we want the meshes to be 5 inches in there. Let's generate the preview and see what that looks like. Where'd it go? Is it turned off? Okay, so I need to part mesh controller. So it didn't do something. Let's try that again. All right, so generate the preview. Yeah, let's try it with a smaller mesh density and see what happens. Okay, so it might not have liked 5, and it might have been because over here, that's not going to be 5 inches. I'm not sure why this isn't doing anything. Okay, so there it generated a mesh from the preview, although I couldn't see the preview in there. So if I edit the node properties, it'll give you the option for the initial temperature, submodel that it's supposed to go in, and the starting ID. And you can see that this is a little too coarse, so let's delete this TD-Fem mesh. And let's try to do this again with a bigger absolute size. Let's try 3 inches and see if that takes it. And it should be showing me the differences. here we go. I got to turn on meshes and mesh importers. Yeah, it's kind of quirk. I'll do that automatically. All right, so here you can see this is the mesh it created with a size of 3 inches for the one. I could try to generate the preview instead. Let's try and do it with 5 instead. Generate the preview, and you can see it's gotten a little coarser. So it's not too bad. I could probably live with that. It's not too many nodes. So I'll edit the node properties. Let's call this deck 3 mesh. Edit the surface properties. So for all the free surfaces, where do you want the radiation? So let's say it's going to be black anodized. It's always going to be top out. Conduction, we're going to make this be 0 thickness. You can still assign a material. Generally speaking, your surface coat, you want to be 0 thickness to not add conduction to it, but you need this to do radiation. You need this to do contactors, because you can't contact to a 3D solid. You can't radiate from a 3D solid. So in order to use some of those features, you need the mesh surface coated on the outside. You could add the insulation, so on and so forth. Edit the solid properties. So what do I want the material to be here? So this applies to the solid elements that will be created, and the other one applies to the surface elements, planar elements that will be created. Okay. So I can say, all right, I'm happy with this. I'm like that. So let me go ahead and generate the mesh. And now I have created elements and such from here. If I didn't like it, like before, I could delete the mesh and then go back and redo it. And when I'm happy with it, if I don't want to change it anymore, I can release it from the controller, which would now say, make all these elements and make them as solid elements and planar elements, and they would appear as solid elements and planar elements and no longer be attached to the mesher. So that's the capability there. Now let's see what happens when we try to do that with the ESPA. So we're going to do 3D mesher, mesh part, select this here, generate the preview, and let's again try to do, let's say 3 inches. That seemed to be a decent size. Generate the preview. And so you can see, I got a heck of a lot more dense mesh than I do over here. And part of the problem is that, I have these tiny little fillets and chamfers and things like that on this geometry that is just not very well suited for being able to do a mesh. And that's with 3 inches. So this is where I find the mesh controller to be pretty limited in its capabilities. If you can work well with your CAD people, your mechanical and mechanical designers, you can get them to clean up the chamfers and fillets and make a lot more right angles, get rid of all the holes and things like that. But it requires considerably more work to clean up the geometry to make it suitable for meshing. And again, you are limited by the fact that this is going to be tets and tries for your elements, not bricks, not quads. So it's a very basic mesher, but it's there for use. There is a second product that Colmore & Ring has. I haven't used it much. It's called TD Direct. It interfaces with Space Claim. And Space Claim is a good defeaturing geometry cleanup tool, and they have some meshers in there. And so there are ways to link thermal desktop models to the mesher that's in Space Claim, which is considerably more capable than the mesher that's in TD. By and large, I found, for my purposes, that auto meshers just create too many elements to be appropriate for most thermal models. I would never want to send that to somebody and say, yeah, let's run that, from a radiative point of view. It's just too detailed for the purposes that you need for thermal. So I am very much a proponent of building and controlling your meshes by hand to be an appropriate level of granularity for thermal analyses. So, but to each their own. All right. So that's it on the mesh controllers. Okay, that's probably a good break point here. So, okay, so I would say this will probably be a good point to wrap up, and then we can finish up with the components and the deck and things. So, do we want to take 5 minutes of questions before we break for lunch?
Yes.
Okay. So, any questions on what we've shown, the meshing, the mesh controllers, comments, thoughts, wishes? Correct. So what you could do is if you had a perfect surface as a curvature, and then you had the faceted surface, you could put a small ring just behind it that was very, very narrow and make that a blocker surface so that now no rays can get through there. So now you've closed that gap with a blocker surface. Would be a way to do it. So they do have a way of plotting the rays geometrically on there. I think it's limited in what it can do, and if you're firing 50,000 rays, you might see a whole bunch of rays all pointed, and a few that escaped to somewhere where you didn't expect them to, that would tell you, yeah, you might need to go look here. But it is difficult to find. The other thing is whether the views through the gaps and the stray areas are large enough to be output or not. So it might be that, yes, you have a gap, but if you say, I only want radiation couplings that have a BIJ greater than 0.001, you might not have gotten, it might not be a large enough view to register. You're welcome. Okay, any other questions before we adjourn for a brief snack? You'd probably set none. Yeah. So not an analysis group, it wouldn't see it. It would be like it isn't there. None, it would participate in the radiation, so it could absorb, it could reflect, but it won't have any energy tallied and associated with the nodes assigned to the surface. Yes. Okay, good. Okay, you have an hour to eat and think about more questions. Thank you for your attention so far.